And Smriti.
Hi, everyone. I'm Smriti P. I'm so excited to introduce you all to Prishaa. A really quick intro on me. I'm a software engineer at Google in the city. I work on search, and I was actually a mentee with this program a long time ago when I was in middle school. I started mentoring when I was in college, and it's Prishaa is now I think my 15th mentee. So Prishaa is a sophomore at Marymount, and the first thing that struck me was her passion for sustainability. I think she's been kind of thinking about that and learning more about that since middle school, which I think is really incredible and inspiring. She had a lot of ambitious and multidisciplinary goals going into this project and trying to answer really important questions like how should we allocate our funding to reduce carbon emissions? So really complex stuff. And I think she was able to learn a bit about coding and data science and more about sustainability and put it all together. So I'm really proud of what you've accomplished, Prishaa, and I'm really excited to see where you will take it and keep, progressing in this field of sustainability. So take it away, please.
Hi everyone, I'm a 10th grade student at Marymount School of New York, and my research was mostly focused in how should we allocate funding to reduce carbon emissions. Next slide, please. So a little intro on my mentor, Smriti. So as she said, she's a software engineer at Google in New York City, works in search, and more specifically uses machine learning for search query understanding. She was an undergrad major in computer science with a minor in music at MIT, and then completed her master's there with the Music Technology Lab. So she's also had experience in multidisciplinary work, so we were very compatible in that sense. She grew up in the Bay Area and plays piano and dances and was a mentee with Magic in 7th grade. Next slide, please. So some more specifics on my project. So the official, very long, hard to break down name is modeling the decline and rise of CO2 emissions in various countries to pinpoint specific problem sectors and recommend funding allocations, which is a mouthful. So more specifically what it is, it's in a generalization, a set of static math models to kind of first depict the decline and rise of CO2 emissions, and then depict how historically funding has been allocated for different sectors. And based on those two, I wanted to incorporate a predictive component, but due to lack of time, I kind of had to use my past research experience in the topic to make generalizations. But then during the summer, I hope to continue and incorporate a predictive component. So why I selected this project is I'm interested in utilizing Python in interdisciplinary projects. Growing up, I always had a very hard time answering the what is your favorite subject question because I liked them all and I wanted to combine all of them. So I was able to do that here. And I visualized the data as it pertains to the real world issue of sustainable development. And in the image on the right, I've actually highlighted the specific sustainable development goals that my project targets. And it's largely based on the sectors I focused on, but there's plenty of overlap between them as well. Next slide, please. So just an overview of my research process. First, I had to find data. I found emissions data first, and then funding data. And the source I used the most for this was the World Bank. However, I also used some US government data more specifically. Then I developed visualizations, correlated them, and then drew conclusions based on the historical data models. And then I tried to predict future trends and how resources should ideally be allocated. Next slide, please. So some more specifics on what I actually learned. So via Code Academy, which Magic generously provided for me, I was able to take a course on Python for data science. So I had done a bit of Python before, but this was kind of my first introduction to Python, more specifically with data science and data visualization. So I explored data sets from Kaggle, the World Bank, the United Nations Environment Program, or UNEP, and the Sustainable Development Report, which is an international report run by Sustainable Development Solutions Network as part of the UN. I used Colab notebooks, which essentially runs very similar to Jupyter notebooks, which I had experience in before. So it was easy to use in that sense. And when I analyzed the historical data, I broke it down into three main parts with my mentor. So first, sourcing the data importing the data and then cleaning it and then sorting it. So the second half of dealing with the data was visualizing it. So I focused on 4 main libraries for this purpose. Matplot library, which is also used partly in MATLAB, which is a kind of Python, but more difficult and used for data visualization more specifically. So I didn't use MATLAB. I stuck to Python and I used the subsect matplotlib. SNS, which stands for Seaborn, Pandas, and NumPy. The visualizations I used were bar charts and time series. Next slide, please. So how far I got in this project, I also had plenty of goals at the start that I wasn't able to fully achieve, but that is okay because that sets a path forward for me to continue next year and during the summer. So first, with my mentor, I completed relevant sections of the Code Academy course, sourced emissions and funding data, applied the learnings in the Colab notebook. So more specifically, data ingestion, cleanup, and visualization, and then developed initial conclusions from this data. In the future, I hope to dive deeper into the historical data and include a predictive component that utilizes artificial intelligence and machine learning to incorporate supplemental data sets and funding recommendations from that. Then I hope to formalize my conclusions and do this in a report or write-up. Next slide, please. So my magical experience. Some highlights were identifying a specific research topic. At the start, I had a lot of ideas with how I wanted to go. And thanks to my mentor, Smriti, I was able to kind of narrow that down to a specific topic, a main research question that I was able to break down into sub-research questions and tackle by finding specific data sets for each of the questions. The next highlight would be debugging Colab code. This was something that Smriti and I spent countless hours struggling with. It was the most challenging part of the project, debugging the code. Then some more specifics on challenges. Outlining project goals is very similar to identifying the specific research topic. Scheduling was a bit of a challenge, but we made it work out. We were in different time zones at different parts of the project. And deciding which library to use for each data model. So before, I never really had to pick between the data model because I would take online courses and it would just tell me which one to use. But Smriti kind of helped me to pick which data model would be most useful for each graph. Next slide, please. So here are just some screenshots of the visualizations I was able to create. So at the top, it'll show the funding data set visualizations. So the one on the left would be from the year 2000, and the one on the right would be from the year 2020. So these are stacked bar charts, so they kind of show the sectoral breakdowns, and the sectors are listed in the legend on the right of them. And in the stacked bar chart, it kind of adds up all of the emissions per capita of each of the types of each of the greenhouse gas emissions from the different sectors in one graph from a selection of countries. So as per the World Bank data, I had access to almost all of the United Nations registered countries, but we had to limit it to a selection, so we chose these. And at the bottom, you'll see visualizations from the funding data. So these are time series, so they show the increase or decrease of national funding for specific sectors over time. So the one on the left you'll see is general public services. So this would be infrastructure, buildings, roads, that sort of information, as well as energy. Energy being the most carbon emitting sector, as we discovered from the research. Then in the middle, you'll see education, how much funding has been dedicated to that. And on the right, you'll see health. Next slide, please. So just a demonstration on just walking you through the process we had. So first, we had to establish the main research question, which was, how should funding be allocated on a national level for sustainable solutions? And we had to break it down into sub-questions, and then we cataloged each of the data sets. So we used 4 main ones over here. The first 3 are pertaining to emissions data, as that was largely non-standardized by nation to nation, since this project was drawing upon global data. It was very hard to find data sets that kind of use a standard measure for each country's emissions data. And then over here is my emissions data Colab notebook. We first imported all of the data sets using the libraries. And then over here, just kind of a .head, .tail, .describe visualizations of what each of the data sets contain. The first 5 values, last 5 values, a general description of what's going on. So once we had that baseline understanding of what is in this data set, we were able to kind of filter out the values we didn't need or didn't want. And more specifically here, for example, we focused on pulling out data points from the year 2000. So this is an example of a visualization. It's very cluttered at the bottom because that's all of the countries listed there. This is not the selected values version. But over here, it is cleaned up and you can see the specific values of specific countries. So over here, we incorporated an interactive component. So for example, it starts off showing Cameroon's data, its sectoral breakdown. But then there's also a dropdown that we've toggled using one of the parameters and incorporated, for example, a change to Bosnia and Herzegovina. So we made this one using matplotlib. Yes, over here, it's just showing all of the countries that are incorporated in this data set. So there's quite a lot to choose from. So over here, we filtered out all of the other data and selected only from the year 2020. And then the same visualization as above, but for the year 2020. Over here, once again, an interactive component where you could toggle the dropdown. Over here, we also started with the funding data set by importing and preparing the data. So importing it, cleaning it. We established a helper function here. So this is a function to plot the time series. So we just kind of defined the plot series function. That way we didn't have to keep coding it over and over again for each of the indicators implemented. We could just call the function and it would run by itself. And more on the indicators. So we had to select specific indicators such as general public services, economic affairs, environment protection, health, and education from the World Bank data because there were so many indicators to choose from, I think well over 100. So we kind of had to filter down and pick ones that we could connect to the sectors outlined in the emissions data. So this one also has a drop down where you could see the funding values over time in the time series graph by country. So for example, we start off with United Kingdom. So over here, we have a visualization of the environment protection values. So once again, showing the same selection of countries as before. You'll see an outlier here, the United States. So we actually had an empty cell in the data set for those values. Once again, a testament to how not all of the measurements taken for a World Bank data set are standardized across countries. So the United States had empty cells. So we had to replace that with values of 0 in order to get a visualization to appear. Next slide, please. Initial conclusions. So some things that we could glean from these two data sets, minus the predictive component part, would be it is most important to increase funding for sustainable solutions in the general public services sector. So this is the most polluting one in terms of increasing over the years. So greenhouse gas emissions from the buildings and transport sectors increased the most over the past 20 years. And these sectors have overlap with the general public services category of national expenditures, which was shown with the second data set. And the general public services funding has been gradually decreasing on a global scale, which is not what you'd expect if you look at the visualization of the emissions. You'd expect it to increase. So that is one interesting thing we gleaned. And the second one is there must be additional national investment in the environmental pollution sector. So this is primarily because the electricity and heat sector is typically the highest polluting sector. Of course, there are outliers. There are anomalies, but this is a vast generalization of what we saw. And this sector of electricity and heat in the emissions data corresponds to the environmental pollution category of the government funding data. And the funding for environmental pollution solutions are on a slight upwards trend in most countries, but it is not sufficiently matching pace with the emissions output, which is increasing at a much faster rate. So just a disclaimer, these are initial generalizations. Country-specific suggestions cannot be made based on the present data, as the needs and capabilities of each country vary. And also there may have been zero values from some of the countries, as we didn't have full cells for all of them. Next slide, please. Thank you. And if you have any questions, I would be happy to answer. Yes.
Thank you for teaching me. Was there, and this is what you and the other person had to fill in the data, was there any considerations for the average?
The average, do you mean, oh, sorry, just to repeat the question. The question was, if for the data sets where we had to fill in a value of 0, could we have just taken the average and inputted that instead? So I just have a quick follow-up question so I could understand the question better. Do you mean in terms of taking the average of values for that specific country or for other countries? So for that specific country, for example, for the United States, example I pointed out in the video, we actually received empty cells for all of the United States values. So there was no average to be taken of. That is definitely a great idea, and we would have loved to implement it, but due to restrictions, we could not. Yes.
It said early in the presentation, I had some experience with Python for data science. So what was the difference in the way you were using Python between how you had learned before versus doing it for this project?
Thank you. So the question was, what is the difference between the Python I had done before this project versus how I use it in the context of data science here? That's an excellent question. So prior to applying it to data science, it was mostly focused on just general basic concepts such as printing, running, just the fundamentals. I didn't have as much of an in-depth experience as when I applied it here. So with the data science, I was able to not only explore new libraries such as Matplotlib and NumPy, but I was also able to manipulate lists more efficiently to fit the data. Was able to create, for example, the dropdown is a more not necessarily advanced or experienced feature, but definitely not something that I saw before studying Python for data science. Thank you. Yes.
Project, did it reinforce or change any of your perspectives on the topic, like going into it?
So actually it did in some ways. So I expected as national governments will have access to much better data than I did. I would have expected them to notice the trend in general public services, for example, increasing and then match funding accordingly. However, that was not the case. So that kind of challenged my preconceived notion that governments would be able to use visualizations such as these to easily spot decreasing in funding and address that accordingly. Any other questions? Oh, yes.
How this project like combine your different interests, like different subjects. I was wondering, like, I know you said moving forward, you also want to work on like you kind of had some initial conclusions and plans for sort of how to like remedy these conclusions. How do you think you can use like Python and coding to like not only sort of have like the data for like different sectors, but also the data for like how like sectors can be more efficiently sort of like funds can be more efficiently allocated and like demonstrate that.
So the question was, how can I think it was, how can I expand the findings on funding for specific sectors in the future?
Yeah.
Okay. Okay, so for potential solutions compared to the present, that would actually require the incorporation of a new data set specific to not only solutions funding, but how many solutions and how effective that has been in decreasing CO2 emissions in different sectors. So what I'd look for is a data set specifying how much funding has been allocated to solutions in each sector and how much funding has been, how many emissions have been reduced due to certain solutions. So then I could correlate it with the first data set and see how many emissions are left in between what was actually emitted and what was able to be reduced. Yes.
I was wondering what the, like, years for the data sets were, so like, when did this data begin, when did it end? And I was also wondering, besides like, the gradual trends you saw, were there any like stark increases or stark decreases where you saw like, oh, this country clearly put money into this program at this certain point?
Yes, that's an excellent question. So the question was, I believe, twofold. So the first part was, or the second part was there any sudden increase or decrease that we saw in the data? And the first part was, sorry,
Years?
the years,
Like, when
yes.
this data started?
So why we chose the certain years or what?
Yeah, when was that?
When was it? Okay. So the years were 2000 and 2020. So the reason why we chose these years was actually because the second data set started and ended with 2020, whereas the first data set started with 1990. So just to be able to have more accurate visualization, we wanted to start and end them on the same year. And 2020 is fairly recent, so it was most important for the visualization. And for the second part, we actually did notice a significant increase. For example, if I go back, oh, sorry, can we go back a couple of slides? To the one with the pictures, this one. So for example, we'll see in the one for general public services, for example, Iceland increases significantly compared to its counterparts. This was somewhat surprising, but not really, because Scandinavia has been known to introduce much more sustainable solutions compared to countries from the rest of the world. However, the amount was certainly jarring, and that came as a surprise. Yes.
Why was there no data for the United States?
So that was actually another big surprise, that we had no data for the United States. I believe, based on what I've learned before doing this project, the measurements for finding emissions and funding, especially funding, because that varies definitely by country, is not standardized even when the UN is conducting its research and trying to fill in data sets. So it might have been attributed to either the United States perhaps pulling out of the experiment where they were getting data for that, or not contributing to it, or most likely because they didn't have a standardized form of measuring the funding values. Agreed. Thank you.